Kirchhoff's law, that is KVL, that is your Kirchhoff's voltage law. Here I have made the diagram for the numerical question. Okay. Now in this question you can see that all of you EMF is given, that is EMF E1 and E2. You can write E2. Two EMF are given. Okay. Or this is what, these are the battery, these are the EMF means these are the batteries. Okay. And here you can see that the E1 voltage is 4 and E2 voltage is 3.5 volt. Okay. And here you can see that I have written 1 ohm and 2 ohm. So 1 ohm and 2 ohm is what? It is the internal resistance that is present in the battery. Clear? Now what we have, according to the question, here we have external resistance, that is 4 ohm and 3 ohm, and third one is 10 ohm. Okay. Now when we have get this type of question, first we will check here the positive side. This one is positive, this one is negative in the battery, we know that. In the cell connection we know. So current will flow from this side. Okay, this is the direction of the current. Okay, and then when it will come over a Q, then it will move like this. Clear? Again it will come like this, and from this side the arrow sign is like this. Okay. Now in the same condition over here. Okay. So in this condition what happened? The current will move from positive. So it will move like this. Again it will come over here. And then again in this junction, we are getting here the junction over here. And then again it will move this direction. And then again this it will move to this direction. Okay. So we have made what? Arrow, because with making with the arrow you get the idea, the direction of the current, we get the direction of the current. Okay. Now let's suppose, because we know that what is the KVL, the KVL or Kirchhoff's second law or is the sum of all the voltage drop around a closed loop in a circuit is 0. Okay. So that we have to find out. The finding of this one, first you can see that here at the point Q, you can see the one arrow is this side, another arrow is this side, and third arrow is over here. So this Q is behaves like a junction. So according to the first law, that is KCL. Okay, that is first law. You can able to write according. Okay, or we can able to write apply the first law also. So when you apply the first law, you can see that the Q is behave like a junction. Okay, and when Q is behaves like a junction, and we can able to give the name of the current. Let's suppose this one is 4 volt, this one is 3.5. So this one is more than that of this one. So can I able to write this one is I1 and this one is I2. So this is same, this one is I1, this one is I2. Here the current, that is, these two current are called entering current, and this one is outgoing current, so that I can able to write I3. Okay, so I will write I1 plus I2 is equal to what? I3. Clear? So this is my equation 1. Now because we know that this Kirchhoff's law or KVL law is applicable for closed loop. It is applicable for closed loop. So here first we are going to find out for a closed loop. So first I am going to find out for this, because here it is the direction of the current is moving like this. You can see that from the diagram also, and I can able to take a closed loop. So my closed loop is what? PQ. This you can see that from the diagram, PQS, PQSP. Okay, And in the previous class, I have explained you regarding how we are going to apply the law of KVL. Okay, so here you can see that the current is I1 and it is in the direction of same resistance. So when it is in the direction of same resistance, it is positive. So we can able to write 4I1 plus, now it is moving to over here, it is moving over here, and it is what, I3, and it is in the same direction, so we can able to write what, 10I3 plus, again you can see that after this it will move over here, then it will move up, and again it is in the same direction, but here we have another resistance, so I can able to write that resistance also. So that is going to be same I1, because 1 into I1 we get 1 on I1 only, okay, is equal to what we have, because you know that what is the KVL law, that is sum of the IR is equal to sum of E. We can able to write like this. So according to that, so this side is going to be what, this side is what, the value we have 4, so we are going to write 4. This is my equation what, 2. And you can able to solve this one also. How we are going to solve? You can see that 4I1 plus 10I3. What is the value of I3? 10 I1 plus I2 plus I1 is equal to 4. Again you can solve this one. So 4, this one is 10I, this one is 10I2. So we can able to write 4 plus 10, 14, 14 plus 1, 15. 15 I1 plus 10 I2 is equal to 4. Okay, so you get equation. I have already written equation 2, so you write 2a. If I have written already. So now, so this 2a equation is for this circuit only, PQSP. Now we can able to find out for the same, which circuit, this circuit, that is QRSQ. Okay, so we are going to write QRSQ, because we know that we are using this law for a closed loop. These are the closed loop. Okay, so you can able to write the closed loop also, closed loop. If you wanted to write, you can write closed loop. Now when we apply over here closed loop, so QRSQ, we have written this one. Okay, so you can see that the direction is reverse. You see that the direction is reverse. So when the direction is reverse, then we will write what, minus what happened in this case, we will write minus, and then 3 into I2, we will write 3 into I2. Okay, then the next, after that you can check here, we have what, we have 2 ohm, that is the internal resistance. So again minus 2, current is going to be I2, same, again it will move over here, and then it, see the direction. Okay, because we are applying QRSQ, it's like this, so again it's moving over here, then again it is what, opposite. So again what I am getting, minus 10, and this is I3. So we can able to write, in the place of I3 we can able to write I1 plus I2. Okay, is equal to what, you can see that what the value we have, EMF, that is 3.5. Write the value 3.5, that is okay, and then you can solve this one. Okay, solve these equations. So while solving, we get 3 plus 2, but the sign is what, minus, and again you solve this one, minus 10I minus 10I2 is equal to 3.5. So these two, when you are going to add it, what you get? Minus 15I2 minus 10I1 is equal to 3.5. We can able to write, but here you can see the direction. The direction of this one is what? Direction of this one is positive to negative, and you know that the current, when it is moving in the direction of negative to positive, then only it is plus. But here it is what? It is plus moving from positive to negative, so it is minus also. So when it is minus, so this all minus are going to be removed. So we can able to write 15I2 plus 10I1 is equal to 3.5. Okay, this is your equation 3. Now you will solve equation 2a or equation 3. So what is the value for equation over here? The first value that we have, that is 10I1, not this one you write, 15I1 plus 10I2 is equal to 4. Okay, and here what we have? 10I1 plus 15I2 is equal to 3.5. This is my equation 1 and this one is my equation 2. Okay, now when you solve, after solving, what you will get? You get the value of I1, I2 and I3, that is the combination of I1 plus I2. So that is your work that I think you can able to solve this one. Thank you, students.